Hi, I'm Sumit Dutta, and I'd like to present to you Wildlife Watch. This is a web app I developed. Wildlife Watch is a web app that helps tourists plan their trips to the national parks. It tells them what animals are likely to be seen in the national parks, and it gives information specific to a time of the year, as well as the trails within a park. This is more information than what you typically get in a national park brochure. And Wildlife Watch aims to tap into the $40 billion that consumers spend annually in their trips to the national park. To make Wildlife Watch, I combined data from a couple of different sources. I first looked at the National Park Service animal inventories, where you can see that there are information about the common names for an animal, as well as the categories of the animals and how abundant these animals are. So you can see a lot of what those animal abundances look like. Then I also get comments from alltrails.com, which are left by people who visit the trails. It says the date and that the comment was left, which trail that the comment's about, and the comment data often includes mentions of animal sightings. So I make use of that data specifically. In order to get my data, I did a significant amount of web scraping. So I used Selenium to get the JavaScript loaded comments from alltrails.com. And I also used Selenium and Beautiful Soup to get the animal names from the National Park Service site for many national parks. Then I began my natural language processing on the alltrails.com comments by tokenizing and lemmatizing the nouns in each of the comments. So in each comment, I take these nouns and then I do a fuzzy match with the animal names that I pulled. And I do a form of sentiment analysis on these identified animals in the posts. So if a sentence mentioning an animal has a word related to the site, I assign that a higher score of 1.5. That's a high sentiment showing that the animal is relevant to be seen. If there's no words related to site, then I'd only give it a score of 1.5. And if there are negative words saying that the animal was not actually seen, for example, I didn't see a bear, then the comment did not contribute to the score because the animal was not seen. So in the end, I'm getting a score for each animal for each month and trail in a national park. So for each of the trails in the national parks for any month of the year, I have a prioritized list now for which animals are most likely to be seen based on their scores. I validate the animal scores that I calculate by comparing them to the animal abundance that I have from my National Park Service dataset. When there is a score that's above 0 for an animal, what I see here is that those animals are in fact common or abundant animals. This makes sense because users are talking about animals that they're seeing, which will generally be common or abundant. In addition, there is a weak but still positive trend between the animal abundance and the animal score. I would expect that it's not a very strong trend because there's other factors like the enthusiasm and the visibility of animals. But I try to control for that by picking a moderate difficulty trail. I still have an R-squared of 0.35, which indicates a weak correlation, but I see that the positive trend between the score and the population is what I was looking for. Let's see how Wildlife Watch works. So if we want to go to Big Bend in April, we can see, first of all, what the animals are in the park overall. And if we hover over those trails, we can see what animals are likely to be seen in those trails. So I have this data for several national parks, and it is built using AWS and Dash and Mapbox. To tell you a little bit more about myself, my background is in electrical engineering and computer science. I have a PhD from MIT and a bachelor's degree from the University of Illinois Champaign. I was most recently in the semiconductor industry at AMD, where I improved the manufacturing efficiency and yields by implementing machine learning models in production. During my PhD work, I did a significant amount of image analysis and high volume simulation data processing and analysis. And I worked on magnetic logic circuits that I had applications for, such as convolutional neural networks. Also, I've done a number of other internships before, such as at NASA, where I've done some geospatial analysis. I have a large variety of data experience, and I'm very interested in data science because I think it can